Good day everyone, I'm Kathleen Fea Mllames from BT Garments 1B. Welcome to Mathematics in the Modern World. So let's talk about the inductive reasoning. What is inductive reasoning? Inductive reasoning is the process of reaching a general conclusion by examining specific example. When you examine a list of numbers and predict the next number in the list, according to some pattern you have observed, you are using inductive reasoning. Let's proceed using inductive reasoning to predict a number. We have two examples. First example, 2, 4, 6, 8, 10. So by observing the number, we all know that there is the pattern because its receiving number is 2 larger than preceding number that we predict that the next number is 2 larger than in the 10, which is 12. And for our second example, we have 2, 4, 7, 11, and 16. What comes next? By looking and observing the numbers, the first two numbers is differ by 2. The second and third number is differ by 3. The third and fourth number is differ by 4. And the last two number is differ by 5. So we predict that the next number after 16 is 22. By differ by 6. So inductive reasoning is not just used to predict a next number in a list. So herein, use inductive reasoning to make a conjecture. Pick a number, multiply by the number 8 and 6 to product, divide the sum by 2 and subtract by 3. So complete the above procedure for several different numbers. Use inductive reasoning to make a conjecture about the relationship between the size of the resulting number and the original number. We pick 3 as our original number. Then proceed will produce the following original number 3. Multiply by 8 times 3 equals 24. The second is add. 24 plus 6 equals 30. Third, divide. 30 divided by 2 equals 15. The last one is subtract. 15 minus 3 equals 12. If we can see, the result is that the number 4 times the original number. We conjecture that following the given procedure, a number 4 times to the original number. Next is pendulum. But first, what is pendulum? Pendulum mostly used in inductive reasoning. According to Galileo Galilei, used inductive reasoning to discover that the time required for a pendulum to complete one swing, called the period of the pendulum, depends on the length of the pendulum. Galileo did not have clock, so he measured the periods of pendulum in heartbeat. The following table shows some results obtained for pendulum of various lengths. For the sake of convenience, a length of 20 inches has been decided as 2 units. Here is the table. It showed the length of pendulum units, also of the pendulum in heartbeat. This is pendulum. The period of pendulum is the time it takes for the pendulum to swing from left to right and back to its original position. By knowing pendulum, our next will be using inductive reasoning to solve an application. First question is, if a pendulum has a length of 64 units, what is its period? Now let's see the table in question. We need to know the length of 64. Looking for the table of the length of pendulum in units, all at them as a square root. Square root of 16 is 4. If square root of 4, it will be 2. Back to the question. So the length of 64 is 8 because the square root of 64 is 8. We conjecture that a pendulum with a length of 64 will have a period of 8 heartbeats.